So next, we've got Alexander, whose surname I can't pronounce. Kmoch, no? Righto. Yep, righto. I'll let him come and pronounce it. Alexander is from GNS, and he's going to give us a presentation on data output. Thank you.
You can say Kmoch or Kmoch. Okay, yeah. Good day, everyone. Where would I put that? You give me the 5-minute thing? Yeah, cool. Yeah, so my name is Alexander Kmoch, but you can just say Alex. Thank you very much for being here and for bringing up that energy after lunch. A quick introduction because while I'm working at GNS, my current role is being a PhD student. I'm enrolled with AUT University in Auckland, but my work is based at GNS in Taupo in the SMART Aquifer Characterisation project, which is an MB-funded 6-7 years project. It's about the characterization of New Zealand's aquifers. So my perspective is a bit biased from the groundwater geology perspective, yet particularly through that hydrological aspect, I see we'll have a lot of commonalities. My research partner is also University of Salzburg, the Center for Geoinformatics. And I'd also like to thank Horizons because I got a really big bunch of data to play around with. And I'm in the 3rd year now of my PhD. So in the beginning, I thought I'm really visionary, and now I'm coming towards the end. I see now like these emerging patterns, and everyone is doing it, and I wonder what I write up in my PhD if everyone's already doing it. So aquifer characterization is a research project that does a couple of actual hydrogeological research aspects, and one of them eventually is data synthesis and visualization. So through my sort of quite unique setup as a student, I had the chance to visit different institutions, to work in different places, and I saw a lot of different data centers and their related data infrastructures, their needs and their demands, and I am to apply this experience now into what's so-called we call it a smart portal. Basically, it's not only a website; it's a sort of a framework in itself. And today I want to explain a few of the technical intricacies that sit as a website. So I have a background in computer science. I worked a couple of years in Germany in a Berlin data center, and then in a software company that produced ERP software for utilities and water providers. And then I decided I want to do a bit more of an immersive learning experience again, and decided to switch to science. And now I really enjoy being on that interface between applied IT and science. From the beginning of my career, I was inspired by that simple statement: the network is the computer. I'll probably bring out something quite obvious here, but this is actually now more true than ever, really, in the age of internet and cloud computing. And this has been mentioned by John Gage in 1984, so at least I was already on the world, but it was the 5th employee of Sun. And I always found Sun being one of the pioneering companies in terms of their commercial grade Unix, networking, also Java. Java is more popular than ever, which is now everything is sort of merged into Oracle a couple of years ago, like 7-8 years ago. So the legacy lives on. Okay, to talk about visualization, I have to mention a few things that prior to visualization, because visualization cannot exist in a vacuum, because the data has to come from somewhere in the network. So we have a variety of input data sets, all sorts of places in the network, and the visualization is practically a function of the data into something that humans can consume. So visualization is for humans, right? So it's an output, but the input data for the visualization has to be processed in a way to create, from data pieces, create pieces of knowledge and information. And this information eventually has to be consumed, to be accessed by people, right? So otherwise the visualization is sort of useless by itself. So when you think, for shortness sake, I'm not speaking about analog media, so I'm talking about digital media because we're speaking of data. So we can think we can rethink the whole data life cycle from data collection to data processing and to visualization. And visualization by itself is not a dead end of the data. It's like, it's not like it's done. But the sources, when you aggregate data from different places, you have to consider that you have data sources in some places and then transform the data, maybe mesh it up, and then create new information. So if you think of that in your network structure, then we want to probably consider that these data sources, I would like to call them services, right? I mean, we call them services. And these services break them down into smaller, more manageable bits, and then we can aggregate and orchestrate those services, because we can use different data input sources, be it from external of the organization, be it from internal of the organization. And because web services sit on top of HTTP, which is a really well-known protocol, it's very easy to secure, it's easy to manage. We can then build, I call it indicator modeling space here, but call it however you want to. So you can have your internal network here or your external partners, but then for the network security itself sake, you would have your place where you create those visualization, or where you create your information bits that you want to convey. And this can be small things like graphs or small images, but can also be that, in fact, larger simulations will run, and then you would also feed those also with those web services, like Sean, for example, showed. So my main key takeaway here at this point is to embrace the web, really, because the web has been around for a while, and HTTP is here, and HTML, and it has been for a while. It's not going to go away anytime soon. The modern web browser now has all means, capabilities to create engaging, compelling, and powerful animations and visualizations from lean, slick graphics to 3D in the browser. So with WebGL and HTML5, you can create everything in the browser, really. And the measure, when you talk about different information sources coming from the different web servers, because you can then selectively say, I want to mix up all those things for that target audience and those things for that target audience. If you create web consumable visualization outputs, those things can be shown everywhere. Can be shown on web, can be shown in desktop application, being just rendered within the normal content, and can also be rendered on mobile. And the data that you need to create those visualizations, the more granular the more granular you provide it on the way through that data life cycle, the more flexible you will be in the end of where you want to produce your visualizations. So they've been lately called the 3 V's of big data, but nevertheless, I mean, these we have to challenge all right now too. This, the ever-increasing volume of data, the variety, and the variety means not only different formats, but also structured and unstructured, and files and database data sets, and eventually the velocity of data. So, which is mainly for us in our space related to time series and telemetry data. Okay, for that, spatial data infrastructure standards come to the rescue. I'm a bit of an advocate for open geospatial consortium standards, but not only because they're really, really practical and they provide means of a structured format which is machine readable, and not only like an Excel spreadsheet or a CSV file, but also they capture the domain knowledge or the meaning and the structure of fields, so it's easier to build applications against them. And in fact, the Geospatial Office in Linz has been encouraging some of those standards officially in SDI since 2007. And some of them were actually official standards, actually on the website, like WMS, the ANSLIC metadata standard, GML, and others, which live in the same ecosystem, which is the good thing, have been picked up by the community and it's sort of got its own dynamics. And one of the great candidates is WaterML, for example. So then I'm a bit of a technologist myself, so I'm not so much entangled, let's say, in policy. Yet technology serves as a supporter for human processes eventually. So we often get distracted a little bit by the intricacies and the complexities of technology. And then we tend to talk about technology itself all the time. But I realized, of course, the technology is just a means, a projection of the human processes that we are engaging with each other or with external entities. So technology should always support that and not, live by itself. And a similar aspect then is the choice of your technology. And I picked out a bit on database itself, but particularly with those OGC supports. And you could also, for the hydrology domain, we would have Hilltop and Kistes and Aquarius Informatics. So there's a variety of tools of technology available, and as Marcus so nicely said, so what's so complicated? So the technology is sort of there. I mean, you have to choose, but the reasons, you have to think through the reasons why you would choose a solution. And so I'm taking this example here. So this is from DB Rankings. So it's a website that does some statistics on popularity of databases. And of course, we have the commercial ones really, really far on top. So, but then also we have non-commercial solutions pretty quickly, like filling up the rest of the top 10. And you would wonder why, because the discussion is typically open source software or those community editions, they don't have all the features. So, and the other thing is the commercial support. So who would you, I don't want to say the blame word, but someone has to take the responsibility, and sometimes you want to invest money and you just want to have the solution done. But the challenge here is that you cannot just use technology to solve the problem, because you have to involve the people. Because even if you hire trained people that have the experience with the technology, they're still serving and working on your data. So they need to know your data. So eventually they will become part, more intimate with your organization. So I don't see people as being that exchangeable and just say, okay, you have that qualification and it's easier. So one of the investment question that you could do is you could cut down on licensing cost and and invested in people training, for example. But it does not necessarily mean that you're really better off with a commercial or not a commercial database or a commercial product. One of the questions that you could ask yourself is, you will start a project and you invest money and say, okay, we go with the commercial product, and it will start nicely and easy. But then after some time in production, there will be some issues. So then you go to your provider, and the provider fixes this, but then they do some tuning, and they say, okay, there's some things in your data model, for example, that is not quite supporting the performance, but your staff still had to manage the data. So you see, you have to consider both sides of the coin, really. And another interesting aspect here is, in fact, we're always talking, mostly, particularly in the GIS community, we're talking about relational database systems. And they are great for their purpose. But if you think about that high-level abstraction of web services sitting on top of databases, then suddenly the database itself doesn't become as important anymore. And if you break up your data silos to be more flexible, then what you worry about is the data modeling on top of your database. So how is the data presented? And here's again where those OGC standards come into place. So you question yourself, if you want to have your monolithic database, and I'm not saying this as a bad thing. You have your big database, which is great, and you do your work at that level, or because eventually you want to produce outputs, and you want to, be able to lift your visualizations into the web and even into mobile and through the cloud. You just have to be aware of a couple of things. And the other thing is that even those ones, even unstructured, so-called no SQL database, not only SQL database, show up in the ranking, are very popular because they are just data stores that are created for a particular purpose. So you have to take into consideration the purpose of that data store. So in SMART, in fact, when it came to be in a groundwater sand pit, probably 5 years ago, that group that made it up, in fact, SMART is save money and reduce time, which is really nice. So, and I've been with the SMART project now for around about 3.5 years, and we starting to build solutions around distributed databases and distributed web services, where we embrace that the data comes from different places. I'm not sure, Aristotle or Plato already said, you can't quite change a system. You build a new system and you move on. And if you've split your architecture reasonably well, then you can do that building block-wise. Because one of the things with big databases, like once you have the data model in place and you want to change things, it becomes exponentially more complicated. So this is another consideration. So I'm a bit of a, maybe because I'm one of the younger people in the room, I'm a bit of a child of the internet anyway, so I sort of rather embrace that level on top of the database, and the database are just different parts where the data is stored. Okay, and here, one of the examples here, like this is one of the SMART case study areas, this in the Nongotahe area, and we pull in this digital temperature measurement in a stream, so we pull that from one place, and then we link that to the earth beneath our feet. It's mainly for the Bay of Plenty area, where some geological models been done, and so one of the things you can do really nicely in the web, you can mesh up different things. So what are your data challenges? What's the ultimate purpose? So you have the people and you have your purpose. And it was a really nice presentation with the ECAN earlier today, and everybody loves maps. I mean, most of the data, in fact, has a spatial component anyway. But I think Esri made that up a couple of decades ago when they said like up to 80% of data has a spatial context. So this has never really been proved, but nevertheless, there's some inherent truth in that a lot of data has spatial context, and visualize it on maps, particularly within your region, for the public access. The first thing they do is they go, where they live, they go and look, what data is here in my place. And speaking about visualization of raw data versus visualization of, let's say, curated sampling data, if you use again that higher level approach, then you would just do the technology behind it would be pretty much the same. You would just have to add different metadata items. That one is raw data. It could be, for example, the quality coding, and the other one is curated data and is quality checked and maybe even checked against field sheets or calibrated. And while you use those technologies, the next simple step is, in fact, you can also leverage into a mobile because it uses the same underlying transport mechanism. So it's very, very, very easy. Once you embrace that sort of level of orchestration and aggregation, you suddenly become very, very agile in creating visual outputs. So one of the latest things that I've been working on is a bit more complex. So groundwater is particularly a fuzzy thing, and it's not as easy as just measure surface water flows and or rainfall. So there's a couple of models that sort of you do a couple of realizations of a distribution, but what you have to do is you have to feed it with input data. And one of the major problems with that, again, is the same issue that you probably have when you share data, like for water quality. It's like, I have to get to that database and here, and then I have to reformat that Excel spreadsheet. And so, and the same issues is what the scientists have when they do, some of those assessments within your region, for example. So one of the things that I'm now working on is that if you have those data sources, then you would feed, for example, a complex model, and it would fit in here in that space, basically, right? So you have different data sources because groundwater is even more, you have geology, and you have meteorology, and you have surface hydrology. You probably have pedology. So there's all sorts of things going on. So that's why from the beginning I had to embrace that fact that this data can come possibly from everywhere. So and because some of those legacy models don't really speak OGC, and we're putting some efforts in to put wrappers around those things, and this would make it probably possible to share such a result of such computation within the same means that you do in for more, for you, probably for your perception, more standardized data, and this can lead to sort of a paradigm shift where you at first have a scarcity problem, which is data access, and it is data pre-processing to get it in the right formats. But then if you suddenly can use it because you make it available and you have it easily and automatically sort of accessible through, for example, standards, then the domain sort of explodes, and you can you can do new business level models, you can do new models of collaboration. This how Lava suddenly exploded. That was pretty good to see. And then you can really think about, hey, what's my target audience? And because you can just, I don't see it like, often you see those things like cogs, that grab into each other, but I see it more as a shopping basket. You say, I need that, and I need that, and this gives a more lightweight feeling about that. And one of the last things that are important, particularly in those things where you mesh up, that's why I was asking all these sort of nasty licensing questions, but I'm a technologist, not because I want to, annoy somebody, is because you have to measure up so much data in those things, it's really important sort of to be able to sort of track data quality, lineage, because you still need to know where this data is coming from, because that needs to be part of the results. You have to propagate those things through. That is a bit challenging, but we sort of have the things in place already. And 3D, as I mentioned before, visualizations now sort of in the new sort of web era have reached a new level. So this you can see actually in the browser, and you can like move it really nicely in 3D. There's still some, you need to do some. Well, I need to do some better navigation so that you can feel better. But so this is the Horowhenua area. This I think it's the Tararuas, right? And so here is the Horowhenua area. This is Lake Horowhenua. This is a normal digital elevation model, which is also pulled in through those web services. It was just a normal coverage. And then those are typical map layers, just draped on top of that. And this is another process, just one of those visualization processes that then produces something that you can see on the browser. You can probably do it as a little plugin, or if you want to do like a full thing. And this allows you now a 3D view of things. So I thought that would be pretty cool to show. And this also works on pretty much most of the modern phones that I've been playing around with. So and this is HTML5 and WebGL. There's no Flash, there's no Silverlight, there's no plugins. I mean, Flash has a pretty big saturation in the market. It's about like, 97% or so. The problem with Flash is one of the things is security, and it has some providers now of the cloud, media providers start to drop support for Flash, which is pretty interesting, in favor for open standards again. So here we come again, open standards. So, and to wrap it up, my messages for you is rather look into web services and how you keep your infrastructure agile. That sounds a bit like a buzzword thing, like like a new thing. But in fact, service-oriented architecture has been around for ages. It's based on web services. The protocols are comparatively simple, at least the transport protocols. It's easy to manage security. If you model the data sources as web resources, that gives you a whole new level of granularity. And then you can do those mashups, and then you can think about social media. Secondly, open standards. I mean, this is just the way to go. Back in the days, I was like, oh, there's an industry standard, and it's a de facto standard because there was some big providers that do that, and like most of the people just use that commercial software. But nowadays, the tides are in fact changing, and more we see standards being adopted by communities who just drives it and pick it up, and it's developing its own dynamics. And eventually, it's still about the people though. People who process the data in your organization, who work on the data, analyze the data, and also the people who you process the data for, to show data, to visualize data for. And this can be, the public, it can be partners, different groups in the public. It's often sort of generalized, the general public, but of course there are different stakeholder groups in the public, and so you want to know your audience, and you want to know the people. Thank you very much for your attention.
Any questions? One over there. Just while we're waiting for a microphone, I'd just like to ask, where you were talking about web services.
Yeah.
Where do you see Creative Commons fitting in that world?
It's like with metadata. So in that, do you hear me? In terms of spatial data infrastructure, you have the actual data sets. Some of the data sets have, because I was earlier asking DataGov-NZ what sort of markup do they use for the, do they use doublet core, or do they, so there's nothing. But in many of those standards, there's explicitly fields where you would put disclaimers or links to the license in. So it was just like a property on the data that you would explain somewhere. That's why I said attribution is basically enough, and so it's sort of it can be part. You can also put another license in there. So this is sort of transparent, like security on HTTP and the web stuff is sort of transparent because it's so well understood, and it's just it's sort of woven into the fabric.
As not one of the youngest people in the room.
Sorry.
I wonder whether with the social media and what have you, times are changing quicker than we can keep up, and should we be concentrating more on pushing out data in a way that we know it's robust and it's usable by all these different people who are creating apps and social media? So should we be focusing more on the quality and the amount of data, or the type of data we're putting out, rather than trying to keep on top of all the web platforms and all this kind of stuff that everyone else is doing?
I think that actually goes hand in hand, and it's actually not two different things. The community, so like, for example, we here in the room, also NIMS, OGC in the global space, it's not so much that they do separate stuff. It's really, you will always have representatives from one group and another, and there's always quite some cross-pollination. So there's probably a little bit of a, I wouldn't call it misunderstanding, but probably like a bit of a perspective thing. Because if you embrace one of those, the other thing comes along by itself pretty much. I see it like that. Cool. Thank you very much.